Okay, I believe we're live. Mic check. We're listening to music that will make Luigi cry due to nostalgia. These things just keep popping up on my YouTube recommended, so that's great. And we're actually starting a new topic, but it's really similar, well, heavily relates to our last topic. So, our goal for this week is to solve quadratic equations. Now, there's lots of ways of doing this, but I guess we'll just jump right in. To solve a quadratic equation, the first thing we want to check for is if we can factorize it. So we're going to have three methods of solving a quadratic equation throughout this week. The first one's, it may not be the easiest, but it's certainly the first thing you should always check for. So I guess all quadratics are going to look like this. So they're going to look like, I hope that's not too loud. Okay, so every quadratic, no matter what, will look like this. Sometimes I don't have a term like this, like it might just be x squared plus 3. That's still in this form, it just doesn't happen to have this term. But you may not see it like this, it might already be factorized. So you might have, I guess in the last topic, we would have seen it look two different ways. Last topic we saw it look like this and this. Actually, I'll do both. No, I don't want to use C twice. I'll use H and K. Okay, so all of these are quadratic equations. If you just expand this, it's going to look like this. If you expand this, it's also going to look like this. So every quadratic looks like this. Our goal is to be able to draw these things. That's the whole point. So this topic's called quadratics and the parabola. These are all parabolas. It's got an x squared. It's a parabola no matter what. It looks like this. It's just a matter of what it looks like and if I can draw it. So if I'm able to factorize it easily like this, or if it was like, actually I should have another one in here. If it was like, let's do a H. If it's in one of those three forms, then I can draw it. That's what we spent all last topic doing. So I can draw this, it's just moved C. Or maybe can't draw this yet. I can draw this, it's just moved up and down. We're going to move towards drawing these, but essentially all I want to be able to do is draw this. So the first way of doing that is by factorizing. So we just need to remember one thing that's called the null factor theorem. So I want to be able to turn anything that looks like this into one of these. Once I've done that, I put them equal to 0, which is what solving a quadratic equation is going to be like, and then I use the null factor theorem. So the null factor theorem is if I've got two things times together and they equal 0, then either P has to equal 0 or Q has to equal 0. And that was how I got my two solutions. So just think of this in terms of P and Q. If I've got two numbers here and I have to times them together to get 0, one of them has to be 0. There's no numbers where these are both not 0 and I end up with 0. That doesn't make any sense. So one of them has to be 0, and that's where this theorem comes from. That allows us to solve quadratics. Now we have done this before, but I guess let's jump into some examples. Let's do 1 and 2. So if they're already factorized for you, so if they've been nice and factorized it, I'm not going to use x's. 3, 2. So if they're already factorized, you might see it in one of these two forms. Actually, you might see it in three forms. Let's use the three forms that are at the top. Okay. So once factorized, you could see it in one of these three forms. So they're the three forms that I've got up here, basically, maybe not this one. Okay, so what I do is I pretend that one of them equals 0. So remember I do this. I like to normally draw arrows. So I pretend that equals 0. So that means 4w would have to equal 0. That means w has to equal 0. Or this equals 0. And then I solve that. So move the 2 over. W equals minus 213. And that's done. So therefore, w equals either 0 or negative 213. So that was how we solved quadratic equations. And yes, we have done that before. And yeah, I do draw these arrows. But essentially, once you go, you just pretend this is 0, you've got an equation, and then you pretend this is 0, and you've got another equation. And here we're just solving one-step equations. Okay, this one. So I pretend that equals 0. So 5m plus 2 equals 0, or 2m minus 7 equals 0. So when I solve this, I've got 5m equals minus 2, m equals minus 2 on 5. This is 2m equals 7, m equals 7 on 2, and you can really just leave it like that, I guess. Now, there's a couple of ways of looking at this next one. It's essentially the same set of brackets twice, so it's kind of like if this was x minus 2 and this was x minus 2, then I'm going to have the same equation and solve it twice. So really, you could just rewrite this as x minus 2 equals 0, because another thing you could do is just take the square root of both sides. I guess you'd write a plus or minus, but plus or minus 0 is still just 0. So if you ever just got a squared, you can kind of just omit that. Just got to be careful that there's no number out here. Okay, and that just means x equals 2. Now, you might think, why are we solving quadratic equations when my whole goal is to be able to draw them? Well, we're going to, I guess, move towards that. But the whole point of finding these values, or I guess why we find these values, is they have significance to the graph. So I don't know if you, I guess, might remember. Did we draw? Yeah, we would have drawn these. Now, let's not spoil it. Okay, so these are if they're factorized. If they're not factorized, then we need to go the extra step and factorize them. So there's a couple of common mistakes I do want to go over when solving things like this. So 4, 5, 6. Okay, 6. And I guess this also comes down to an ability to remember all our different ways that we factorize. So that, and last one. Okay. Now, when you're factorizing, the first thing you should look for is a common factor. So a common factor in here is 3p. So I'm going to rewrite this as 3p outside of 2p minus, gee, I haven't done this in a while, that, and I'm fully factorized. So that's the easiest way to factorize. Now, I've got two things that are equal to 0, so that means either that's equal to 0 or that's equal to 0, so then I can split this up. So that means 3p is equal to 0, or 2p minus 3 is equal to 0. That means p is equal to 0, or 2p equals 3, p equals 3 on 2. Solved. Just keep in mind that this squared at the top tells me that there is at most 2 solutions. So just also this one only has 1 solution, so that's why it's at most. So it could be 2 solutions, it could be 1 solution. Some have no solutions, and you would have seen those before. You might have ended up with imaginary numbers or the square root of minus something, and you would have been like, well, that doesn't work. That's why. So you could have at most 2. Now, if I'm looking at something like this, a common mistake is to do this. Go 2x squared minus x, and then I'll move the 15 over, and then look, I can factorize. So I'll take an x outside of 2x minus x, and that's equal to 15. And then I go, okay, that means x is equal to 15. That means, oh, what have I done here? That's meant to be a 1. That means 2x minus 1 equals 15. That means 2x equals 16. That means x equals 8. Now, I have seen that, and some people might think that's silly. Some people might be like, well, yeah, that makes sense. It doesn't, because the null factor theorem means null means 0. So you have to have it equal to 0. If I've got these two terms, this is what I've basically broken this up to is, okay, I've got 2 things times together to equal 15. That means one of them has to be 15. Well, no, that's not true at all. But if this was 0, yes, one of them has to be 0. So that's why we don't break them up with a number on the outside. So this here is a big no, don't do that. Instead, what you're going to do is do the old type of factorizing. Oh, this isn't a nice one. Wish we had a nice one. Oh well. So I guess when you've got all these terms, there's 2 things again you've got to look for. First thing, common factor. But can I like think of a number that times to this and adds to this? I hope people remember that. But in this case, I can't, because there's a 2 here. So what I could do is try and divide by 2, but these aren't even numbers, so I can't do that. So what I do now is I go, okay, 2x minus x minus 15. This is a, b, c, and I always write a times b plus c. No, a times c plus b. I wonder if people remember this. Okay, a times c is minus 30. So that was this times this. Plus b, that's just minus 1. Okay, and then what I do is I think of two numbers that times to give negative 30 and add to give negative 1. So times to give negative 30, add to give negative 1. Once I've thought of those two, so maybe I'll write them over here. 5 and 6, minus 5 plus 6, no, minus 6 and positive 5. That makes sense? Okay, so then what I do is I break this middle term up into this. So I go 2x squared minus 6x plus 5x minus 15. And you kind of try and put the nice ones next to each other. It doesn't matter, you can put them in opposite orders. It'll still work, but you just try and line them up so that like my 5's next to my 15, not my 6. Okay, so that's equal to 0. I'm going to run out of room. Okay, so now I factorize in pairs. So this, I hope, is all revision, but it's been a while. So I factorize these in pairs. So the first thing, common factor, I've got 2x outside of x minus 3. And then the hope is that your next set of brackets also has an x minus 3. So I'll take a minus 5 outside of x. That's going to be a plus, isn't it? Oh, okay, I'll make a plus minus 3. Okay. Okay, and then what you do is you group in. No, I've got a common factor of x minus 3. So I pull that out. X minus 3. Everything that's left, 2x plus 5 equals 0. And then I've got my quadratic equation that is factorized. So I can go, okay, well that equals 0, and then that equals 0. I feel like I've just thrown a lot at you, but it should all be revision. So that means x minus 3 equals 0, and 2x plus 5 equals 0, x equals 3, x equals minus 5 on 2, one step. Okay, last one. Again, I need all of these terms on one side of the equation so that it equals 0. That's my goal. And I know that I have to do that because I've got two terms here. If you just had one term, like if this wasn't there, then you just go ahead and go, you know, that on 5 on 6, and then y equals the square root of that. But I've got this term here, so that means I've got to move everything to one side. And you could try and leave the y squared thing positive. So 6y squared plus 7y minus 5 equals 0. And now I can start factorizing. Just notice that this is in this form, okay? And notice that all the solutions, or I guess all my questions look like this, and the solutions all look like one of these. So my solution looks like, let's go over that at the end. Let me just actually solve this. So I go a times c plus b. That's a, that's b, that's c. I'll try to do this one faster. A times c is negative 30, b is 7. Two things that times to negative 30 and add to 7. I'm thinking 3 and 11. 11 minus, what am I thinking 11 for? 10 and 3. 10 and minus 3. That took a while. 10 and minus 3. 10 times minus 3 is 30. 10 minus 3 is 7. Okay. So then I break up the b term. So I've got 6y squared plus 10y minus 3y minus 5 equals 0. So all I did was turn this term into these two, which was from here. Then I factorize in pairs. So boom, boom. I've got a common factor of 2y. So 3y plus 5. And then minus 1. Can't factorize that. 3y plus 5. You can see how my signs were wrong, that's why I took a minus out. So then I take the 3y outside of the whole thing. You've got to remember that that's a minus 1 equals 0. Hello, other teachers. 3y plus 5 equals 0, or 2y minus 1 equals 0. That means y equals minus 5.3 and y equals a half. Okay, so I guess a bit of a summary. Every quadratic looks like this. You want it to look like one of these. So that's the goal. Let's write that. Now, we currently can make them look like this and this. That's what we can do so far. So you'll notice that all of our solutions look like one of these. So, this one kind of does. You could put it in set brackets. This one, this one, this one. These ones all look like factorized. Yeah. So factorized. Once they're factorized, you can solve them. So I can't solve them when they look like this. The goal is to make them look like this. That's the point. We have done that before. Now, this one, so this one factorize, this one factorize. Now, how we make it look like this is actually using completing the square. And we're going to do that again next lesson. But again, that's something we have done. So pretty much everything we're doing this week is revision, but we're giving it a bit of context. So we're trying to make it look like each of these two by factorizing, this one by completing the square. So yeah, I guess that's all I've got to say about that. I feel like I threw a lot at you, but it is revision. So, let me know if you need anything.